Hi, everyone. Like everyone else who contributed these talks, I wish I was giving these talks on Luca's 60th birthday with Luca in the audience. Uh, Unfortunately, I was not to be. But this is a celebration of uh, Luca's academic legacy and Luca's impact on all of us. And Luca's birthday is indeed an occasion to celebrate. So we'll start by saying happy birthday, Luca. I was quite fortunate to get to know Luca, to work with him. He was my advisor, a mentor, a friend, and a person I'm deeply indebted to. And today, I just want to talk about three things I kind of learned from Luca. I mean, I want to make it clear that, okay, these are three things which I think uh, I saw Luca do very well. He embodied this, and I kind of felt inspired by them. Uh, I don't yet claim to do any of them, but I think they are kind of uh, things which I found very inspirational. And so I just want to mention these. And uh, this will be kind of a light talk. I'll mention briefly about some research I was involved in personally as kind of examples of some of these things, but I'll not really get into a lot of technical content. Yeah. And yeah, as three qualities, again, these are things which I've seen lots of researchers kind of do, but I'll kind of mention Luca's particular flavor of those, and some I thought he embodied them in a really inspiring way. So first was kind of just the ability to explore many different areas of research, many different topics, and uh, explore kind of truly like a beginner. So when I first started as an actual beginner, as a graduate student, working with Luca, um, I would be kind of very wary of studying some new topic or be scared, and particularly wasn't sure if just kind of studying something might have any relevant application, or what if I wasn't able to understand it? What if I didn't have the relevant background, and so on? And Luca's response was usually, "So what?" Uh, which was kind of something which was quite admirable in the sense the willingness, the ability to kind of explore something for its own sake, just kind of taking time to deeply understand it. And over the course of years, I kind of saw him do this many times in many different areas. And there's a sort of Zen phrase of having a beginner's mind. So you could really um, uh, kind of get to a topic with no uh, kind of uh, hang-ups about studying it, and just kind of understand it completely within a few years, and then move on to a different one. And I realized that actually a lot of my questions somehow, yeah, it's not that uh, somehow Luca was sure that he would kind of understand some things he was looking at. It's that he had this kind of amazing humility to just be okay with sort of not understanding something for a while and just kind of keeping at it until you understand it, uh, which actually I had to learn. I kind of was an undergrad where I was used to understanding things, and research that's never the case. And somehow this was something I really appreciated learning from Luca, or at least seeing him do sort of exceptionally well, where you could just kind of go to a topic, sort of begin to explore it, ask questions until he understood it really deeply. Okay, and one particular example which I was fortunate to see was that around the time I was in grad school, there's this paper of Green et al. About arbitrarily long arithmetic progressions and primes. And this was seemingly a very daunting uh, work of arithmetic combinatorics involving techniques or ideas which I had never seen. And then, yeah, Luca, as usual, was curious about it, even though it was just in a different area. And then sort of we started studying it. And then Luca had this question that they seemed to be doing something which was, or at least his take on it was related to things in pseudo-randomness, that this proof was kind of lifting the proof of Samraizi's theorem, or using so-called transference principle, which Samraizi's theorem says that dense subsets of integers have arbitrarily long arithmetic progressions. And the idea here was that primes are not a dense subset of integers, but they are a dense subset of another subset of integers, which is pseudo-random. And so somehow a pseudo-random set behaves like the uniform distribution on the integers, and a dense subset of a pseudo-random set behaves like a dense subset of the integers, and in particular behaves like, in a way, to have arithmetic progressions. And later we could formalize this intuition, and yeah, Luca, of course, thought that this should be a more general phenomenon. I mean, can we always kind of make an abstract statement that a dense subset of a pseudo-random set will have a so-called dense model, or will look like a truly dense set in more general settings, not necessarily integers or not necessarily pseudo-randomness related to primes, etc. It turned out to be true. In fact, this was something we discussed on a road trip to Stock 2007, where Luca kind of, this was in San Diego, we were riding from Berkeley, and Luca kind of offered me a ride in his car. I was supposed to go with Luca and Omer Reingold, as a beginning graduate student, kind of somewhat apprehensive about going with these two professors. And then once we were on the road trip, both these apparently serious professors were just kind of dancing away to Bhangra music in the front seats. And I was just puzzled in the back seat as to what happened. But we also discussed math. In that, in particular, we kind of started talking more about dense models, etc. And then later, when Salil visited Berkeley, we kind of all collaborated on this and ended up proving some formal versions of these statements. And those at least embodied how Luca could kind of maybe look at something which was seemingly in a completely unrelated area, just sort of look at it from different perspectives until he understood it, and in the process prove something beautiful. And this was just one example. These are just a list of topics, some from Luca's webpage, some which I added. And these are just some of the things Luca worked on. Just a wide array of topics. And as a graduate student, and even later, it seemed like he essentially did a new PhD every 3 or 4 years. Just kind of started studying something, and like more than a PhD, probably truly exceptional PhD every 3 or 4 years. Just kind of the number of topics he studied, and the kind of the depth at which he understood each of them. This was the first thing, again, which I saw Luca do really, really well. The second was to kind of really understand proofs. And again, as I said, many researchers in theoretical computer science and math have really high standards and kind of understand things really well. The standard from Luca, which I particularly liked, and I've tried to get this quote as accurately as possible, which was that basically you understand a proof when it becomes a sequence of inevitable steps. So there is no magic. There is nothing which is a choice. There is no choice left to be made. Once you have kind of the right mental model, the steps of the proof are just obvious. And this is a tremendously high standard, but this is a standard that Luca often adhered to. And you see him explain a proof, it did indeed, he did indeed make it seem like it was just the only natural thing to do, or it was just inevitable. And I hope to do this sometimes when I understand things. Mostly I can't, but I think this was something to aspire to that I learned from Luca. And again, going back to this example, once we had this sort of intuition that a dense subset of a pseudo-random set should behave like a truly dense set, we kind of had two proofs of these, and the proofs were by contrapositive, that maybe what you are doing is, so contrapositive was that, okay, if one dense model doesn't work, then there is a distinguisher which says that somehow this dense subset can be distinguished from a truly dense set, some candidate truly dense set. You try some other one, that doesn't work, you kind of collect a few distinguishers, you combine them, and then you can build a distinguisher for your original pseudo-random set from the kind of, let's say, the uniform distribution on integers. And this seems to be what happens in boosting. This seems to be what also happens in the proof of so-called regularity lemma. And so Luca wanted to kind of understand if a more general statement was true, if there's a kind of more general kind of regularity lemma which implied all of these statements. And indeed, that also turned out to be the case. In fact, once he was able to kind of phrase the right regularity lemma, he kind of abstracted it out until it was a statement where the statement is longer than the proof, and then the proof sort of writes itself as Luca wanted. So let me give this as my one technical statement in this talk. It's a statement about just kind of approximating a function on, let's say, a finite universe X. So let's say G is some function, bounded function on a universe X. Script F is some class of distinguishers, which is, again, let's think of them as some class of bounded functions. And epsilon is some accuracy parameter. And we want to approximate G. We want to build a low complexity approximation for G such that it's indistinguishable from G by all functions in this class script F, and the indistinguishability threshold is epsilon. And this is an abstract version of so-called weak regularity lemma of Fries-Kannan in the context of graphs. But this says that you can always do this. You can always take k functions from the same class script F and take a linear combination of them, which is H, such that G minus H has low correlation with any distinguisher from this class script F. Yeah. So G and H are indistinguishable. And moreover, H has low complexity in the sense that the number of functions F1 to Fk that you use is small and the coefficients are bounded. So there's some notion of low complexity, which turns out to be sufficient for applications, and again, generalizes Fries and Kannan. And I mean, at that point, the proof was using some potential argument, but now we can actually just say that the proof is, you think of a convex functional on this on H, which is just the supremum over functions in script F of inner product of G minus H and F, which is linear in H, and the supremum of linear functions is a convex function. So you get this convex functional F, and you just minimize that via gradient descent. You will converge in the true minimum is 0. You can take H to be G, and but after a small number of steps of gradient descent, you can get pretty close to the true minimum. And once you do that, you basically get all the sort of guarantees of this lemma. And this H, so if you start with G, which is some dense subset of a pseudo-random set, you build a low complexity approximation H. Because it's low complexity, it can't live in some sort of fancy pseudo-random space. It's actually just truly dense, and that's your dense model. And when you look at a class of distinguishers which count arithmetic progressions, etc., you get the kind of transference principle that was needed. So, I mean, this is just an example of how kind of Luca liked to kind of abstract things, really understand a proof, see what is happening until the proof just became obvious. And this is just one of the many examples, and other talks have mentioned many other examples, in particular, kind of examples of really understanding something, exploring something for its own sake, like Luca's famous paper on extractors and pseudo-random generators. This is just one example where I was personally involved in, so I just thought I'd mention this one. And I think one reason kind of all of us admire Luca so much is that he didn't just stop at understanding things for his own sake, but explained it to all of us and sort of understood things better by kind of explaining it. And in particular, kind of explained this online optimization way of thinking about a lot of these things I mentioned and many more on his blog. So, I mean, his explanation is much better than mine, and I recommend you to check it out. The third was to kind of connect all these areas that he explored. And these are just some of the connections that Luca worked on between these topics that he explored. And again, this is a small subsampling. Luca was kind of exceptional in just being able to see parallels of phenomena in many different areas, together with kind of the breadth of things he explored. Just meant that he had this kind of unparalleled web of connections that he could establish. In his work. And again, that was something I found personally very, very inspiring. Okay. And to go back to the example I mentioned, I said Luca had kind of a more abstract way of thinking about weak regularity. And around 2012, there was work on approximating constraint satisfaction problems using on pseudo-random graphs, using semi-definite programs, very powerful tools. And the original work of Rees and Kannan on weak regularity had been to approximate CSPs on dense graphs. And of course, kind of pseudo-random graphs could be related to dense graphs based on the intuitions earlier. And then Luca and Cheyenne had these new regularity lemmas from pseudo-random graphs, which could give alternative algorithms, really fast algorithms, without relying on these heavy STPs for approximating constraint satisfaction problems on pseudo-random graphs, but also new structural statements just about these kind of graphs. And these are things which I also found later useful in our own work when we kind of worked on coding theory and phrased some of the questions about decoding codes as related to CSPs, which we could also solve using regularity, all thanks to kind of intuitions established by Luca. And I should also say that there was kind of another meaning to connect, which I learned from Luca, that theoretical computer science is not just a web of beautiful ideas, but also a community of wonderful people. And again, the first time I went to a conference with Luca, I was just kind of struck by how kind of warmly he greeted people. Everybody kind of met with him, how he hugged goodbyes when he was leaving the conference. And in general, how sort of warmly he connected with people in the community, how he welcomed me and other kind of junior researchers into the community. And I mean, other than kind of just connecting with us personally, he also kind of connected with a lot of us through his blog, through his expositions, through his lecture notes. So kind of someone who made an effort to connect not just research, not just ideas, but also this community of people in theoretical computer science, and perhaps more broadly in computer science, in data science and mathematics, and many others. So, and that's perhaps or at least one of the reasons why we miss Luca so much. So I'll just end my talk by saying thank you, Luca. We miss you very deeply, and thank you for all your lessons over all these years. Thank you for inspiring so many of us in so many different ways, and we are truly grateful.